Hello, welcome again. We are solving some questions of production engineering or manufacturing science. Question number 35 is a 600 into 30 flat surface of a plate is to be finished machined on a shaper. The plate has been fixed with the 600 side along the tool travel direction. If the tool travel at each end of the plate is 20 uh, average cutting speed is 8 meter per minute, the feed rate is 0.3 per stroke, and the ratio of return time to cutting time of the tool is 1:2. The time required for machining will be option A 8 minutes, option B 12 minutes, option C 16 minutes, and option D 20 minutes. So here length of workpiece is given as 600 and over travel and approach are given as 20 each is 20 Okay, so length traveled in each stroke will be here 600 plus 20 plus 20, that is 640 Okay, speed during forward stroke is given as 8 meter per minute. So the time for the forward stroke will be, that is the length, and that is the speed. So the time will be your that is length in So converting this speed is also in So it will be 8 into 10 to the minus 2 minutes. So time for forward stroke will be 8 into 10 to the minus 2 minutes. And feed rate is 0.3 per stroke. Okay, and feed rate is 0.3 per stroke. So width of each width of the workpiece is given as 30 So this is the time for forward stroke, and now we'll calculate the number of strokes. So as width is 30 and feed per stroke is 0.3 so number of stroke will be 30 by 0.3, that is 100 Okay. So number of forward stroke will be 100. So time for 100 stroke will be 8 into 10 to the minus 2 into 100, that is 8 minutes. So that is the time for forward stroke, as the no machining is performed in return stroke, but it is a faster stroke. So and the quick return ratio is given as 1:2. So half of the time will be consumed in return stroke. So if the time for forward stroke is 8 minutes, then the time for return stroke is 4 minutes. So total time is your 8 plus 4, that is 12 minutes. So answer is 12 minutes. So answer to question 35 is B. Okay. Next question number 36. A 600 long job of 150 diameter AISI 14140 steel is to be turned with a depth of cut 1.5 and feed rate 0.25 per revolution. The optimum cutting speed is 199.5 meter per minute. The machining time is given by option A 5.669 minutes, option B 3.195 minutes, option C 2.126 minutes, option C 2.115 minutes. So here the cutting speed is given 199.5 meter per minute, and diameter is 150 and feed is 0.25 per revolution. So these data are given, and length of workpiece is given as 600 So finding the feed per minute. So finding feed per minute, now V is given as pi dn. So V is your 199.5 meter per minute, and diameter is your 150 by 1000. Okay, or in converting it in that meter. So as speed is in meter per minute, so we can find out that RPM. So RPM comes out as 199.5 1000 divided by 150. Okay. So now the feed is given is as 0.25 per revolution. So if we multiply it by RPM, then we can calculate if we feed per minute. Okay. So that is now feed per revolution is 0.25 and RPM is this. So if we multiply these, then we can get feed per minute. Okay. So time for machining is length by feet per minute. So length we have calculated, length is given, that is 600 mm, and feet per minute is this quantity. So if we divide length by this quantity, then we can get the time for machining, that is 5.669 minutes. So answer is option A. Okay.